in this example, we're not going to be able to solve just through manipulating the equation. We're going to end up having to use some computer utility to solve the equation, to get a decimal approximation to the solution. There are methods in calculus to solve the equation, but of course, we're not in calculus yet, so we're kind of stuck with what we have available. To see why, let's start with something fairly straightforward. Let's say I had something simpler like sine x equals, say, 1/3, right? Well, then I could say, well, if I apply the sine inverse function to both sides, then x equals sine inverse of 1/3. But then there's going to be another solution. If we look at the unit circle to see why, so that's good enough. If, say, sine is 1/3, that's about like here. Y will about here. The y coordinate will be about 1/3, so roughly here, right? But then on the other side, here, there's another place where the sine value is 1/3. And if we think about how those two angles are related, this one's theta, right? If we think of theta is some amount of angle. And on the other side, this, I'm going to call it a gap. If I were to turn that terminal side further and turn the angle into pi radians as a total, I'd be making up that gap. So the amount that's missing here, that we're short of pi radians, is the amount that we do have over here. So it turns out that this angle measure up to there, that's pi minus theta, whatever theta is. So whatever the sine inverse of 1/3 is, pi minus that will be this angle here. Okay? Oh, sirens, I don't know if you can hear that. So pi minus sine inverse of 1/3, right? And then of course we can add the period, so add 2 pi k plus 2 pi k. I'm going a little far afield, but basically we can solve this equation, right? But what if we had something like this? What if I had sine of x equals x, right? And maybe, 0. 0 would be a solution, right? X equals 0. We can tell just by picking numbers and maybe we'll find it. But there's no way to get x by itself. If I try to use the sine inverse, well, I'll say that x equals sine inverse of x. But then, of course, there's actually the 2 pi minus that. And then the plus 2 pi k if we want, right? But this doesn't really solve anything because, sure, I got this x I now have by itself, but this other x, you're using x to define what x is, that doesn't work. So this is not a way to solve it. Now, if I'm lucky and the equation is not too complicated, I just look at it and go, oh, well, here you go. 0 is our solution. That's a possibility, right? But with this equation, we don't have that as a possibility. We're not going to guess this necessarily. But here's what we can do. Over here on Desmos, I have put in these two expressions, the two sides of the equation, as though they're different functions. And if I look for where they cross, well, that would be where the two function values are equal. So the x coordinate where they cross, which, because the right-hand side of the equation was just x. It's sine x minus cosine x sine x minus cosine x equals x. So the y coordinate will be the same. So negative 1.259 is an approximate solution. So I can go here and say, well, if I do sine x minus cosine x equals x, well, then x will be approximately negative 1.259. So I don't have the solution as in this is the solution, but it's a decimal approximation to the solution, and when that's the best you can do, usually that's good enough. Maybe not always, but certainly in an engineering context, that's all you need. I need something that's close enough to get the job done, so this is what you can resort to if needed. And as I mentioned earlier, there are calculus methods. Those also don't find the exact answer. They give a decimal approximation to the answer. So you can get this by hand without a computer, without a calculator. It's just very tedious. You don't want to do it that way. you would have a computer do that, which is essentially what we've done. Although Desmos does not use calculus to get this, I don't think. It uses something else. It's a more algebraic algorithm, I would expect.